All right, let's do some more practice involving tangent lines. So this particular set, we're going to focus mostly on tangent lines. We're just going to assume we found the derivatives of this, which means the slopes of the tangent lines right away. We just want to get practice on doing some sort of interesting problems, maybe a little bit more challenging problems. Now, of course, whenever you're doing practice, the important thing is to do as much practice as you can on your own before you see the answers. Make frequent use of that pause button. Only see the solutions to either help you get past the point where you're stuck or maybe see a different perspective on what the answer is. The more you can do by yourself, the better you're going to be. And you're great. All right, let's begin. You are a safety inspector for a roller coaster ride that is designed to go back and forth along a track that follows the curve y equals a fourth times x squared plus 4. So it looks like we're doing this. So we're moving back and forth along a parabola. As you're walking under the track, you discover a bolt located at what would correspond to the point 3, 0. So probably, I think this problem says we should draw a picture so we can understand what's going on. So let's see. So here we go. Here's our picture. We draw our axes here, and let's draw our parabola. All right. 1/4 x squared plus 4. So it's an upward facing parabola. It's been shifted up a bit. So it's a little bit more shallow. So here's our parabola. And now, what do we have? Well, we're at the point here. So this is at the point 3, 0. So this is at 3. So there's this little bolt here. So there's our little bolt. And we've discovered it. Now, of course, we're the safety inspector. We don't like the fact that our machines are falling apart. That's a bad thing to do. So what do? Well, we believe it came off the coaster as it was moving on the track and flew in a straight line. Look at that. They italicized the word straight line. So it's like, oh, okay. It's moving in a straight. Okay, that's important. We're going to come back to see what that means. So determine the points that you should inspect on the track to make sure there is no other damage. In other words, the points where the bolt might have come off. So it's going to fly in a straight line. So what is going to happen? Well, if it's following the motion of the track as it moves along, as this coaster moves along, so it came off the coaster. So it's going to follow whatever the motion of the coaster is. So if here's our coaster, so here we are, and I guess we should get the full experience. Here we are, and we're going, whee! Okay, so yeah, now we've truly got the full picture of what's happening. Now, what it's going to do here is if it's coming off the track, it's coming off the coaster, it's going to follow a straight line. What is that straight line? So what we have is this straight line is really secret code for tangent line. Aha! Now we see where this problem is going. So the setup of our problem, there's this lot of text, but oftentimes if you can figure out what is the problem really after, it doesn't become so intimidating. So what we're looking for is we want to find the tangent lines. And I should say, this is not going to be our final answer, but it's going to be the step that we need. We're going to find the tangent lines to the curve y equals 1/4 x squared plus 4, which pass through the point 3, 0. If we can find those tangent lines, then we're going to understand where we should look. Because once we found these tangent lines, that in particular, we'll know where that point of tangency was, and life is good. All right, so we kind of have a plan. Now, let's figure stuff out. How do we find our tangent line? Well, we say to ourselves, Now, we might actually make a sound, as in like, let me think about this for a second. But we don't have to think too hard, because it's not so bad to find tangent lines. What we have is that, for example, we have y minus f of a is equal to f prime of a times x minus a. This is if you use your slope-intercept form of lines. Now, our f is our function, 1/4 x squared plus 4. So I can write this as y minus, parenthesis, 1/4 a squared plus 4 is equal to f prime of a. Well, the derivative of 1/4 x squared plus 4, this is a quadratic, we've done these before, that would be 1/2 a times x minus a. All right. So if you give me any a, then that is going to give me the tangent line at that value for x equals a. Now, what do we need to be true about our tangent line? Our tangent line has to pass through the point 3, 0, which means I need to guarantee that 3, 0 is a point on this line. Well, how do I know if 3, 0 is a point on the line? The answer is I plug in x equals 3 and y equals 0, and it has to be true. Okay, so we're going to plug in y equals 0, so 0 minus 1/4 a squared plus 4 is going to equal 1/2 a times, plug in x equals 3, 3 minus a. Now, notice what do we have? We have one equation and one unknown, namely, what is a? Great, wonderful. This is a woohoo, we're making progress. All right, so what do we do next? Well, now we're going to just be very careful here. Minus 1/4 a squared minus 4 equals, well, this would be 3/2 a, because I can multiply that 1/2 a in, and then minus 1/2 a squared. Yep, that's true. Okay, now let's put everything on one side. Oftentimes when you're dealing with an equation, it's nice to put everything on one side because then you have something equals 0. 0 is a friend. Make frequent use of 0 if you can. So if I move this across, add 1/2 a squared, that would get us up to 1/4 a squared. Move that across, that would be minus 3/2 a, and the minus 4 is still minus 4. Now, let's get rid of our fractions. Multiply by 4. If we do that, we'll get to where? Well, we'll get to a squared, and then here, minus 6a, and minus 16 equals 0. Now, what are we looking for? Well, what we're looking for is, we're hoping it factors. Okay, so let's, fingers crossed, it factors. Now, the end, that's negative 16. All right, that's true, negative 16. And so that means I need two things to multiply together to give me negative 16. That means we're going to have opposite signs. Now, 16, there's not a lot of ways to do it. There's like 4 and 4, and 2 and 8, and 1 and 16. And when I add the numbers up, I need to get to negative 6. Well, that kind of leaves us with 2 and 8. And if we think about what's possible, well, 2 and 8, well, how would that work? Well, I need to end up with a minus 6. So that says I need to have a subtract 8 and then a plus 2. All right, so that's what we need. Equals 0. Now, remember I said 0 was your friend? Here's how 0 is your friend. So if I have two things multiplying together and I get 0 out, one of them has to be 0. Okay, so either a minus 8 is 0 or a plus 2 equals 0, which means that we have a is 8 or negative 2. So there's two possibilities for a. All right, now, are we done? Not quite, but we're really close. Actually, we're really, really close. What we've now found is what a is, but what did a represent? It's important to remember what things represent when we're doing it. If you look back here, what a represents is the x-coordinate for the point of tangency. So what we've done is we found our x-coordinates. So we know that our our answer, there's going to be two of them. So what are they? Well, they're going to be 8 comma something and -2 comma something. So how do we find our final answer? Well, we plug in these values. -2 squared is 4 times a fourth is 1 plus 4 gets us to 5. 8 squared, 64 times a fourth, 16 plus 4, 20. And therefore, these are the 2 points that we should go and check to find the bolt. That's where it probably came off. All right. Good. Now, let's do another one. All right. So let f of x equals x cubed minus 6x squared plus 11x. And some questions. Part A. Determine the y-intercept for the tangent line to f of x at x equals a. And then part B is find the value for a for the tangent line where I pass through the origin. So something's happening here. Now, I don't know exactly what this does, but I can see the fact that there's an x here. And what does that tell us? Well, it says the curve passes through the origin, and I don't know what else it does, but, well, I actually don't know what that curve looks like. So we're just going to have to go on faith that something happens. Well, let's pretend it does this. You know, most it's a cubic, it goes up and down. I'll say it's doing something like this. Well, notice that it actually does pass through the origin, because if you plug in 0, you get 0. And it's saying, well, let's see if there's another place where when you take a tangent line, it also passes through the origin. So you might have something like this. Now, I don't know if this is the right picture, but you see how there's another place where the tangent line shoots off to 0. These points are actually important. In fact, in economics, they sometimes are saying, well, that's what you're after, but that's a story for a different day. Okay, so the y-intercept of the tangent line to f of x at x equals a. Now that's actually pretty straightforward. So let's just do it generically first. So y minus your y-coordinate, that's f prime of a times x minus a, or you can write this as y is equal to, if you distribute this through, f prime of a minus a times f prime of a, and then don't forget the f of a that came across, plus f of a. So this part right here, that's your y-intercept. So this is the y-intercept of your tangent line. All right, well, that's good to know. Now, what do we do with that information? Well, what we need to do next is to say, what's our specific function? So we need to, here it is. So in general, it's minus a f prime of a. Well, the derivative of x cubed, if you do the work with limits or some other method, 3a squared minus derivative of 6x squared, well, 12a. And then 11 will be x, derivative will become 11. All right. Now, plus, and then plug in a in. A cubed minus 6a squared plus 11a. So, let's see, what do we get? We get minus 3a cubed minus a minus 12a plus 12a squared minus a plus 11 minus 11a plus a cubed minus 6a squared plus 11a. All right, the 11a's cancel. Then we get the a cubed minus 3a cubed, that's minus 2a cubed. Then we have 12a squared minus 6a squared. That'll be plus 6a squared. All right, so that's that's what it's doing. That's what it is. Now, what can you do? Well, we can clean it up a little bit. Why? Well, look, they have things in common. In fact, I can pull out a minus 2a squared. And if we do that, we're going to be left with a from the first term and minus 3 from the second term. Okay, so, this should be part B, not part A. We don't do two part A's, we do a part A and a part B. All right, determine for which a not equals 0, the tangent line will go through the origin. Well, to go through the origin, what's our y-intercept need to be? It needs to be 0. So, well, we see here, that would be a equals 0, but that's the origin. That doesn't help us. So, if we want our y-intercept to be 0 and not be at the origin, that says, we need to have a equals 3. So, the answer for part B is at a equals 3. So, this was at 3. Now, this picture may or may not be accurate. That's okay. We just needed a rough picture to get us thinking about what the problem is actually asking for. All right. Well, that was sort of a cool down after the first one. All right. Now, let's do a good one. Well, they're all good ones. Okay. Find all. That all. Whenever you see that, it's like, there's some work here. Find all the lines which are tangent to both f of x equals 2x squared plus 4x plus 2 and g of x equals minus x squared plus 2x minus 1. Now, if you look at that, your first reaction should be, what's going on? We can actually sketch these because these are not so bad. If you look at these for a second, this 2x squared plus 4x plus 2, another way to write that is 2 times x squared plus 2x plus 1, which is the same as 2 times x plus 1 squared. All right, that's not so bad. How about this other one? Well, you can factor out a minus. So you get x squared minus 2x plus 1. I always like to get a positive number in front of the x squared. Since there's a negative, I'm pulling the minus out, which becomes minus x minus 1 squared. Now, if you do a quick sketch of what these look like, what you'll see is something that looks something along the lines of the following. This parabola, it's opening up. It opens up because of the 2. The x plus 1 is a shift. Now, the question, does it shift to the right or does it shift to the left? Which way are we going? To the right or to the left? We shift to the left. The x plus 1 says that really we're shifting so that the vertex, the bottom of the parabola, is at -1. So you can ask yourself the question, what's the new 0? In other words, what would you have to plug in to produce 0? If I want to choose something that would produce 0, what I would have to plug in into x plus 1, it would be x equals -1. And so it's like, okay, I've shifted in such a way, well, actually it's shifted this way, so that -1 acts like 0 was acting before. All right, so here I have a parabola. It's a little bit steeper because of the 2. So there's this parabola right here. Now, how about this parabola? The negative says I go down. The x minus 1 is a shift. I think you can probably guess which way. It's going to shift to the right. So I come over here to 1, and then it's a little bit more traditional. It's a little bit flatter. Okay, so here are my parabolas. And what we're looking for is a line which is tangent to both. Well, a line which does it, there's actually, you can see it, it's even been drawn for us, though not intentionally. Do you see the line which is tangent to both? It's this line right here. Namely the line y equals 0. That's tangent to both because it's the axis. Both these curves are sitting on the axes, one above, one below. Oh, sorry, that way. All right. But maybe there's more. Maybe there's more. Well, so now we have to find them. Okay, so let's think about it. At the end, one way to check our answer is we better get to the final step and say, hey, we got y equals 0 as one of our answers. If we don't get y equals 0 as an answer, we've done something wrong. And so we're going to have to go back and think about it again. All right, so what do we need? Well, one of the things is when you're looking for a tangent line, it's one approach is the following. Okay, it says, look, I need a particular tangent line. So instead of trying to find one line at a time, what I'm going to do is I'm going to find all of the lines simultaneously, every single one of them. And then once I have all the lines, I'm going to say, well, which ones have the right property? All right, so let's talk about our tangent line. So there's really two sets. I really have two piles. There's a pile for F and there's a pile for G. All right, so let's talk about what's happening for F first. Now, so generically, we're going to have y minus f of a is equal to f prime of a times x minus a. Or I could say y equals f prime of a times x plus, and I'll write as f of a minus a f prime of a. All right, so I'm writing into slope-intercept form, and you'll see why in a second. But it's just perfectly fine. I want to just get a form for the line. So in our case, we get y equals, so taking our derivative at a, we would have 4a plus 4 times x plus f of a, 2a squared plus 4a plus 2, and then minus a times, and take the derivative. Well, that would be 4a plus 4. So we get 4a plus 4 times x plus, all right, let's be careful here, 2a squared subtract 4a squared. So minus 2a squared, 4a subtract 4a. Aha, 0. And, plus 2. And good. Good. Done. Now, that's the tangent line for f of x at x equals a. Now, let's do g of x. And I'm going to do something a little bit different here. Let's think about what we're doing. We're trying to find when tangent lines are tangent to both. But I don't want to use the same symbol a here. Why not? This is an important thing to distinguish here. Suppose that there were another tangent line. We haven't proven that there is, but if there were another tangent line, notice what's true about these two curves. They don't intersect. They might think, okay, well, that's easy to see, Steve. What's your point? Well, my point here is that that tangent line, it might be tangent to one curve here, tangent to another curve way down there. So the points of tangency for the two curves don't have to happen at the same spot. So I don't want to use the same symbol a. So what I'm thinking of here is that a equals where your tangent to your f of x. So that's what a is. And where I'm tangent to the function for f does not have to be where I'm tangent to the function for g. All right, so that's our thing. Where we're tangent for one does not have to be where we're tangent for the other. So we're going to work our way up through the alphabet. After a, the next natural choice is b. All right, so here we go. So y minus g of b is equal to g prime of b times x minus b. So this is just my generic tangent line to g at some point b. So rearranging, we get y equals g prime of b times x plus g of b minus b times g prime of b. Okay. Now, again, we're going to repeat a lot of the same steps here. So y equals, taking our derivative, it would be minus 2b. Yep, that's what it would be. Minus 2b plus 2. So that's our derivative times x plus our plug b in. So that would be minus b squared plus 2b. Or is it not 2b? No, it's 2b. It's 2b. Minus 1 minus b times g prime, which is still there. Minus 2b plus 2. Okay, good. Now, what comes next? Well, the next thing to do is do the same thing we did here, which is rewrite. Minus 2b plus 2 times x plus, here I have a minus b squared, minus b times minus 2b would be plus 2b squared. So minus b squared plus 2b squared would become b squared. 2b, and what else? Well, there is no other. Wait, yeah, there is. See, look, ha ha ha, almost missed it. Minus 2b. They actually cancel. Nice, nice. So b squared and minus 1. Good. Now, and as I recall, what's happening here is that b represents something. Okay, so b equals where we're tangent to g of x. All right, now, here's our great moment where we're going to say, what are we going to do here? We have all the lines which are tangent to f. We have all the lines which are tangent to g. We need to find the ones which are in both piles. So, when are lines the same? That seems like a silly question, but I think it's an important question to ask. When are two lines the same line? Well, it's when they have the same equation. You're like, okay, well, that's obvious. But you might say, these don't look the same at all. And you have to remember, no, it doesn't mean they have, because A and B are stand-ins. We're going to plug in numbers. So when we say they have the same equation, what do we really mean? What we really mean is that the slopes are the same, which is good, and the intercepts are the same. In other words, wherever it crosses the y-axis is also the same. All right, so that's what it means that when we say that two lines are the same. Same slope, same intercept. All right, well, so now we have a plan, and it's a good plan. We're going to see what happens. So we got to set our slopes equal, and we got to set our intercepts equal. And we're going to figure out what happens. Okay, so here we go. So, all right, we're going to have to move up into this upper piece here. All right, so we need 4a plus 4. That's our slope for the function for f has to be equal to minus 2b plus 2. All right, now we can do something. So, for example, I can move the 2 across. So that's the same as 4a plus 2 equals minus 2b. Or if we divide by negative 2, b equals minus 2a minus 1. All right. So, whoops, sorry. Ran off the screen there. b equals minus 2a minus 1. Now, that's from saying the slopes match. The intercepts also have to match. So, minus 2a squared plus 2, our intercept here, has to be equal to b squared minus 1. Now, here's the fun thing, is I already know there's a relationship between a and b. I have it right up here. b is minus 2a minus 1. So what I can do is I can take this expression and plug it in. So that's equal to minus 2a minus 1 squared. And if we square that out, that would be 4a squared plus 4a plus 1. All right. Well, we're getting close. We're getting close. So, all right, we'll move things across. So, we'll move the minus 2a squared across. That'll be, there's a 4a squared there. So that becomes 6a squared. And then, of course, we have the plus 4a. And then we have the 2. Move that across, minus 1 equals 0. All right. Now, our moment of truth. We should check. There is a check, right? What's our check? Well, our check is we know if this is our function f, well, we know one of our answers should be negative 1. And we should check. Well, 6 minus 4 minus 1 is not 0. Okay, that means I made a mistake. All right, now let's see if we can figure out our mistake. So oftentimes what is really quick to do is sort of like say, okay, did we copy correctly? 4a plus 4, yep. Minus 2b plus 2, yep. Okay, which became what? You subtract 2, yeah, that is 4a plus 2, divide by negative 2, minus 2a minus 1, yep, okay, that's fine. And substitute in, yep, b squared. Oh, I see my mistake. You see? You see what I did? There's a minus 1 there. I didn't write it down there. Ha, 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 ha. Minus 1. There's a minus 1. So these actually cancel. So it's not minus 1. It's really what? Well, it's going to be minus 2. Okay. Now, again, there was that check, right? Because we know that negative 1 should be a solution. 6 minus 4 minus 2 equals 0. It does work. Okay. Phew. Now, what can we do here? Well, we can factor out, or we have 3a squared plus 2a minus 1 equals 0. And we already pointed out what if negative 1 needs to be a solution. So we say, okay, that becomes a plus 1 times something equals 0. Well, what does it need to be? I need to end up with 3a squared. So that says a times something produces 3a squared. That's got to be 3a. I need to get to negative 1. 1 times something is negative 1, so that's minus 1. And now, since we know that equals 0, that tells us two possibilities. A is negative 1, or a is 1/3, because I can just set 3a minus 1 equal to 0. Now let's see what happens. If we plug in negative 1, and I can plug negative 1 because that's for a. I plug it into this expression involving a. So minus 4 plus 4 is 0. Then it's going to be minus 2 plus 2, which is 0. So you get y equals 0, x plus 0. And therefore we get the solution, and we were expecting it. Y equals 0. Okay, good. We knew it was coming, and we're glad we got it. Comma, 1/3. Now, here's where we probably have to work a little bit. Okay, so plug in 1/3. 4 times 1/3 plus 4. Well, that's 4/3 plus 4 is 12/3, right? So really, you have 4/3 plus 4. That's 4/3 plus 12/3. That's 16/3. So y is equal to 16/3 x. And now we also have this other piece here. So minus 2 times 1/3 squared. So that's minus 2 times 1/9 plus 2. Well, so that's minus 2 over 9 plus 18 over 9. And if you add those together, what do you get? Well, you get plus 16 over 9. And there you go. There are the two lines. Now, y equals 0, yeah, we could see that by inspection. Y equals 16/3 x plus 16/9. Yeah, I don't think I would have gotten that one by inspection. All right, good. Good, progress. All right, we're ready for another problem now. Okay. Find the two tangent lines to the parabola y equals x squared, which will perpendicularly intersect somewhere along the line x equals 3/8. So this is the line x equals 3/8 here, and we have our parabola, y equals x squared. So y equals x squared means that this is going to be a really nice, very simple, this is almost the simplest we can get, right? So here's our idea. We have our tangent line, and we just follow it, and it's going to hit the parabola somewhere. Now, of course, it's not hit the parabola, hit the line. Every single tangent line hits this line somewhere different. Now, it's the case that, of course, this line can be hit at the same point in multiple ways. So it could be, maybe if I take this tangent line here, that lo and behold, hey, look, they intersect. Now, but if you look at this, the problem is that they intersect, but they don't intersect, here's a key word, perpendicularly. Now, what does perpendicularly mean? Well, it means that they have to be at a right angle to each other. So, right? Okay, so this is going to be important. We'll have to figure that out as we go on. So how do we begin? Well, let's start by writing down our generic tangent line. Now, we have y minus our f of a equals f prime of a times x minus a. In our case, y minus a squared is equal to f prime of a, 2a times x minus a. All right? Or we can write it as y equals 2a times x, then it's minus 2a squared plus a squared minus a squared. So this is our tangent line. Y equals 2ax minus a squared. Now, what do we have? Well, what we really have is we have two tangent lines. So there's one tangent line, y equals 2ax minus a squared, and another tangent line, y equals 2bx minus b squared. Where we should think of the difference is just where is that point of tangency, a and b. Now, what needs to be true? They need to intersect along this line x equals 3/8. That means that if we plug 3/8 in to this side, we need to get the same y value. Because if they intersect, they're going to have the same y value given that x value. So it has to be the case that 2a times 3/8 x minus a squared has to be equal to 2b times 3/8 x minus b squared. All right, that's fine. So what does this become? There's no x. I'm sorry about that. My goodness, I keep writing stuff down. The x is where we replace the 3/8 by. All right, I'll get it right here. This notation will be good. Okay, so we have 3/4 a minus a squared is equal to 3/4 b minus b squared. All right, now what do we do with that? Well, let's bring everything to one side. So we could say 3/4 a minus 3/4 b minus a squared plus b squared equals 0. Okay, well, Now if you look at this, you might say, hey, there's 3/4 in common to these first two terms. So I could write this as 3/4 times a minus b. And then here I have minus a squared plus b squared. Well, that's a difference of squares. So if I'm careful, I can say, hey, that's really minus a minus b, a plus b. And it's true. It's true. All right. One way to see it is you can think of this as really minus, if you like, this piece right here on the end. Let me switch colors for a quick second here, since I'm going to do a little bit of side note. This part on the end, I can really think of as minus parenthesis a squared minus b squared. And then I can do my difference in squares. All right. What do you see here? Well, what do you see is they both have a minus b. So you could factor it out. So that tells us that we have a minus b times 3/4 minus a plus b equals 0. Now that says there's really two possibilities. Either the a minus b equals 0, or this other stuff equals 0. Now, do we want a minus b equals 0? If a minus b equals 0, what does that tell us? It tells us a equals b, which means it's the same line. It's not two lines, it's just one line. Okay, so we know this part is out. So that tells us that this part, this what must be true about a and b. So the fact that they have to intersect along the line x equals 3/8, and just that information alone gives us the following information. Namely, we now have that, I'll put it up here, a plus b is equal to 3/4. Okay, good. Now, what's our other piece of information that we have? Well, now let's think about the thing we haven't used yet. We've used that their intersection along the line x equals 3/8. We have not yet used that they intersect perpendicularly along there. So the question becomes, what does that mean? How do we use that information that they intersect perpendicularly? Well, here's how we can do it. We say two slopes, let's say m, and I'll call it m hat, put a little hat on it. So these slopes are perpendicular, which a little shorthand for perpendicular. All right, if what? Well, normally we say like one of them is the negative reciprocal of the other. Another way to say it is that when I multiply them together, I get out -1. Okay, so two slopes are perpendicular if when I multiply, I get -1. Now, what are my two slopes? There's 2a and 2b. So it has to be the case that if I multiply those two things together, I have to get -1. So 2a times 2b has to equal -1. Now I'm in a good place. I have two equations and two unknowns. So we start working. All right. Well, we can do some substitution. So for instance, we can write this as 4a times something equals -1. Well, where's the something? Well, I'm going to solve here for b, because see, this will be 4ab. So what is b? That would be 3/4 minus a. All right, so let's now expand this out. And what do we get? Well, we'll get 4a times 3/4, so that would be 3a. 3a minus 4a squared equals -1. All right, good. Now, let's move everything across. So, we're going to end up with, moving this over, 4a squared minus 3a minus 1 equals 0. All right, now, what comes next? Well, we want to factor. Does this factor? A lot of things do factor, so what do we need? Well, here we have to think about ways to combine. Well, the -1, not a lot of ways to do that. That says we'd have to get a +1 and a -1. Now, how about the 4a? Well, 4 doesn't break up in many ways either. It's like 2 times 2 or 4 times 1. So 2 times 2, that would be 2a plus 1, 2a minus 1. That's not going to get us to the minus 3a. But 4 and 1, okay, if we put, let's try this. 4 here and a here. Would that work? 4a squared, that's looking promising. Then we have minus a plus 4a. That would give us a plus 3a, and then minus 1. So it was close. Let's try the other way. What if I put the 4 here? 4a plus 1, right? Let's see, that would be 4a squared minus 4a plus a minus, it does work in that way. All right, good. So we end up with two possibilities. a equals minus 1/4, and a equals 1. Now, it sounds like we're going to have two sets of answers, but actually, it's not quite that. What do you notice here? So, suppose I said a equals minus 1/4. Then what do I know about b? Well, to get b, I say, look, minus 1/4 plus what gives me 3/4. The answer would be b equals 1. Now, what if a equals 1? 1 plus something gave me 3/4. Well, the thing that does that is minus 1/4. Now, if you stare at it, it's the same pairs, 1 and minus 1/4, minus 1/4 and 1. That's a good sign. It should be the same pairs because what we called a and b was arbitrary. If I called this a and this b, or if I had called this a and that b, it's still the same set of lines. Okay, now, are we done now? Are we finished? And the answer is no, because what are we looking for? We're looking for lines. Our final answer has to be lines. What we've discovered is where the tangent lines are going to occur. So, finally, we plug things in. So, I can plug in, say, minus 1/4. So, if I plug in minus 1/4 here, what do we get? And we get 2 times minus 1/4 is minus 1/2, then x, and then minus 1/4 squared is minus 1/16. If we plug in 1, 2 times 1 is 2x, 1 squared minus 1. And there are our two lines. And you can check. They are, in fact, perpendicular. Another good sign, right? We wanted them to be perpendicular, and they were perpendicular. Woohoo! Yeah! Good. Good. All right. Now, the next one. Find all the parabolas. Y equals ax squared plus bx plus c, which pass through the points 0, 0, and 3, 3, and also are tangent to y equals 2x minus 4. So we're doing all sorts of variations here. Sometimes we have one parabola, we want to find two tangent lines. Sometimes we have two parabolas, we want to find one tangent line. Now we have a tangent line, and we're after, well, give me the parabolas. Okay, well, let's see if we can figure this out. Now, notice something here. This is a good thing to spot. We have ax squared plus bx plus c. So there's three things, a, b, c. There's three things we don't know right now. All right, well, that's fair enough. It's okay that we don't know stuff. But in addition to having three things we don't know about, there's also three pieces of information. 0, 0, we have to pass through there. 3, 3, and we have to be tangent to y equals 2x minus 4. A good rule of thumb is whenever you're trying to solve something, however many things have to be determined, in this case, 3 values have to be determined, that's how many pieces of information are needed. So we needed 3 pieces of information. So that's a good sign. So let's start with sort of the low fruit. All right, if we pass through 0, 0, what does that tell us? Well, it actually gives us something pretty easy, right? So to pass through 0, 0 means that when I plug in x equals 0, I get y equals 0. So that says 0 has to equal a times 0 squared plus b times 0 plus c, or c equals 0. Okay, we're already a third of the way done. We've already found c. Woohoo! Let's hope they're all this easy. They won't be. Okay, so done. Now, let's go to our next thing. Okay, so pass through the point 3, 3. Okay, what does that say? Well, if I plug in x equals 3, I get y equals 3. So 3 equals a times 3 squared plus b times 3. I already know c equals 0, so I'm not going to bother to write it. I can divide everything by a 3. So what does that tell me? That says 3a plus b equals 1. Or I could say b is equal to 1 minus 3a. All right, now that's good. We've now gone to the point that we can say, hey, our parabola has to look like y equals ax squared plus 1 minus 3a times x. All right, now we're good. So, what's our next step? Well, the last thing we have to figure out is we have to make sure it's tangent to y equals 2x minus 4. Now, here's the thing. We know it's tangent to that line, but we don't know where it's tangent to that line. See, this line, y equals 2x minus 4, there's so many points. There's a point, there's a point, there's a point. There's infinitely many points that it could be. We don't know, and this is why it's going to be extra fun. We've got to figure it out. So we have to think about what's true. We do know a couple of things. All right. So let's suppose we need to give ourselves some names. Let's see. We're going to be tangent to y equals 2x minus 4. Now, we don't know where that point of tangency is, so let's give that point of tangency a name. We need to come up with some new symbols. Let's say it happens at, say, w comma z. So this is the point of tangency where it happens. I don't know what they are. But maybe we can figure it out. What has to be true? Well, what has to be true, there's really two things to be tangent. You have to have the right slope, and you have to go through the right point. Okay, so what's the right slope? Well, what's our slope of our tangent line? It's 2. Okay, so that tells us that 2, our slope of our tangent line, has to be equal to, what would be the slope, if you like, the tangent line to ax squared plus 1 minus 3ax at w, because we don't know what w is, but all right. Well, it would be 2a times w plus 1 minus 3a. Okay, so far, this is, what are we saying? The slope of our tangent line has to equal the derivative where we're tangent. Yes? Are you there? You got it so far? Okay. All right. We're going to make it. Okay, so now we're going to just do a little bit of gentle rearranging. So we're going to move this stuff across. So what does that tell us? Or 3a plus 1 has to equal 2a times w, or w, where that point of tangency occurs, has to be 3a plus 1 over 2a. All right, so now we've figured out where at least the x-coordinate is for that point of tangency. Now, are we done? Well, no, what haven't we done yet? Now that we know where the x-coordinate is, what else has to be true? The y-coordinate has to match. So, the y-coordinate of our tangent line at our point of tangency would be 2 times 3a plus 1 over 2a minus 4. So I'm plugging in where our point of tangency is. Has to equal the y-coordinate, this for when we plug in, again, the same value. So remember, the y-coordinate of the tangent line matches the y-coordinate of the function. So we get a times 3a plus 1 over 2a squared plus 1 minus 3a times 3a plus 1 over 2a. Good. Okay, believe it or not, this is fantastic news for us. Because what are we looking for? We're looking for a. And what do you see here? Lo and behold, what you have is one equation, a single equation, and that equation involves only a. We're basically done. other than the fact that we have to face up and tackle this equation. Small details, but still, we're almost done. Okay, so now we start working on it. Okay, so let's clean things up. So notice here, I can divide by the 2. Here, the 2's and the 2's. So 3a plus 1 over a minus 4, we'll get there, just be patient, is equal to here a, 3a plus 1 squared. Well, that would be 9a squared plus 6a plus 1. Downstairs, 4a squared. Here, what do we have? 1 minus 3a, 1 plus 3a. So 1 times 3a is plus 3a. Minus 3a times 1 is minus 3a, so they actually cancel. If you look, this is really a difference of squares. So it becomes 1 from the 1 and the 1, and then minus 9a squared over 2a. Now, what don't we like? And don't say this problem, because no, this is fun. This is challenging. We like to be challenged. You should never back down from a challenge. Well, what I mean, what don't we like, is fractions. We don't want any fractions. So, how do we get rid of fractions? Well, we're going to clean them up. Now, before we get rid of them, there is a little bit of simplification. I can cancel off a single a here. And I say, well, I have an a, I have a 4a, and I have a 2a. So, to get rid of all my denominators, if I multiply by 4a, that'll work. So, everything gets a multiplication by a 4a. So, in the first term, here the a's will cancel, and I have a 4. So, that would be 12a plus 4. The next term, 4 times 4a, so minus 16a, equals, here the 4a's cancel, 9a squared plus 6a plus 1. Now the 4a and the 2a, well, we'll be left with the 2, so multiply, so that would be plus 2 minus 18a squared. Okay, wow. All right, I ran out of space, so I'm going to now move up here. So, what does that tell us? Okay, we're almost there. We're almost there. Don't worry. Hang in there. We got minus 18a squared plus 9a squared. Let's go ahead and let's move everything over. So, that'll come across as plus 18 minus 9a squared. So, we have 9a squared. What else do we have? Well, we have 6a here. So we're going to move that across, so that'll become minus 22a. There's a plus 12a, so 12 minus 16 minus 6 would leave us with minus 10. 9a squared minus 10a. Okay, and what else do we have? There's a 4, a 1, and a 2. So if I subtract, I'll end up with plus 1. And that is going to be equal to 0. Okay, so what do? We took our equation, we cleared our denominators, got rid of our fractions. Ah, good, fractions are gone. It's good to get rid of our fractions. Okay, and then what else did we do? Well, we moved everything over. All right, good. And now what's left? Well, we just got to solve for a. Now, let's think about it. Does it factor? Well, I hope. What do we need? Well, we see 1. Not a lot of ways to do 1. You can either do plus 1 or minus 1 minus 1. The fact that that's a minus says minus 1 minus 1. And what are we looking for? Well, we're looking for two things that multiply together to get 9, add together to get 10. I think there's a good choice here. 9 and 1. So 9a and a. And let's check. 9a squared minus 9a minus a minus 10a. Minus 1 times minus 1 plus 1. All right. So what does that tell us about a? Well, we now can conclude from here a equals 1 or a equals 1/9. Now, we're not quite done. Now we've got to put it all together. So, Because what do we need? What's our final answer? Our final answer is a parabola. All right, so here we go. We know a equals 1, so we get a equals 1, so y equals ax squared. Now b, we do 1 minus 3 times 1. So we have 1, and then we're going to subtract 3. 1 minus 3 is minus 2. So x squared minus 2x. And then c is 0. Okay, so that's our first parabola. 1/9. So y equals a 1/9 x squared. Okay, and what's our other one? Okay, so 3 times 1/9. Well, so 3 times 1/9. That's really 3 times 1/9 is 1/3. 1 minus a third is 2/3. So b is 2/3. So 1/9 x squared plus 2/3 x. And that's our second one. So there are 2 parabolas that satisfy the conditions. We pass through 0, 0. We pass through 3, 3. And if you sketch these 2 parabolas and look at the line y equals 2x minus 4, they are tangent. They'll be tangent at different points, but that's okay. They're still tangent. We did it! We made it! Wow! Isn't it amazing? I mean, it doesn't feel like we've learned a lot of math, but still we were able to solve this problem. It's not about having powerful tools. That's not the goal of math. Our real goal is, let's know how to use the tools we have well. And of course, how do you get to know how to use the tools well? You practice. That's why we're doing all this practice. Such good problems. All right. Thanks for hanging in there till the end.